The phenomenon of space junk, or space debris, refers to the collection of defunct objects in orbit around Earth, including spent rocket stages, old satellites, fragments from disintegration, and lost equipment. This debris poses a significant threat to operational spacecraft, including the International Space Station, ISS, satellites, and even human life, should astronauts be involved. With the increasing number of satellites being launched into orbit, particularly by private companies, the issue of space junk has become more pressing than ever. One of the primary concerns with space debris is the risk of collisions. Even small pieces of debris, when traveling at high velocities in orbit, can cause significant damage upon impact. This risk was dramatically illustrated in 2009 when an inactive Russian satellite collided with a functioning US Iridium commercial satellite, creating thousands of pieces of new debris. This event highlighted the growing danger of space debris and the need for more effective management strategies. The Kessler Syndrome is a theoretical scenario proposed by NASA scientist Donald J. Kessler in 1978, where the density of objects in low Earth orbit, LEO, is high enough that collisions between objects could cause a cascade effect, each crash generating more debris that increases the likelihood of further collisions. This scenario poses a significant threat to space operations and could potentially render some orbits unusable for generations. Tracking and monitoring space debris is an essential part of managing the problem. Organizations like the U.S. Strategic Command, through the Space Surveillance Network, and private entities track thousands of pieces of debris to predict potential collisions and notify satellite operators of possible threats. However, tracking smaller debris, which can be just as dangerous, remains a significant challenge due to their size and the vast area that needs to be monitored. To mitigate the risk of space debris, several measures are being considered and implemented. One approach is the design of satellites and rockets that minimize the creation of debris. This includes the development of technologies that ensure complete burn-up upon re-entry or systems that allow for the controlled deorbiting of satellites at the end of their operational lives. Another measure is the concept of active debris removal, ADR, which involves the development of methods to remove debris from orbit. Various ideas have been proposed, including nets, harpoons, lasers to nudge debris into destructive orbits, and even robotic arms to capture and deorbit debris. These methods, however, are still in the experimental stage and pose significant technical and financial challenges. In addition to technological solutions, international cooperation and regulatory measures are crucial in managing space debris. This includes the establishment of guidelines for debris mitigation, such as those developed by the Inter-Agency Space Debris Coordination Committee, IADC, which provides recommendations on minimizing debris during satellite launches and operations. The legal framework surrounding space debris is complex. Space activities are governed by international law, primarily through the Outer Space Treaty of 1967 and the Liability Convention of 1972. However, these treaties were created before the current issues with space debris were fully recognized. As such, there is a need for updated international regulations and agreements that specifically address the modern challenges of space debris. The commercialization of space presents new challenges and opportunities in managing space debris. While the increase in satellite launches by private companies adds to the debris problem, these companies also bring innovation and resources that could contribute to effective debris management solutions. For instance, satellite servicing vehicles that can repair, refuel, or upgrade satellites in orbit could reduce the need for new satellites and decrease the creation of debris. Environmental concerns are also associated with space debris. The issue is not limited to the space environment. Debris re-entering Earth's atmosphere can pose risks to people and property on the ground. While most debris burns up upon re-entry, larger objects can survive the descent, potentially leading to damage or casualties. One major contributor to the growing problem of space debris is the rise of mega-constellations, large groups of satellites, sometimes numbering in the thousands, being deployed to provide global internet coverage or other services. While these constellations promise significant advancements in communication technologies, they also substantially increase the risk of collisions in space, leading to more debris. Ensuring the safe operation and eventual deorbiting of these satellites is crucial to prevent exacerbating the space debris issue. The concept of space situational awareness, SSA, is critical in managing space debris. SSA involves understanding the current environment of space objects, including their location, trajectory, and potential for collisions. Enhanced SSA capabilities, through improved radar and optical sensors and more sophisticated data analysis techniques, are essential for better predicting and avoiding collisions. In the realm of policy and regulation, there is a growing recognition of the need for international standards and agreements specifically addressing space debris. While voluntary guidelines exist, legally binding international regulations could enforce more responsible behavior in space. However, achieving global consensus on such regulations is challenging, given the differing priorities and capabilities of spacefaring nations. The commercial sector's role in addressing space debris is increasingly significant. Private companies are developing innovative technologies for debris removal and mitigation. For instance, startups are working on spacecraft designed to capture and deorbit defunct satellites and debris. These initiatives, often in collaboration with government space agencies, are vital in advancing practical solutions to the debris problem. Moreover, sustainability in space is becoming a key concern, akin to environmental sustainability on Earth. This perspective advocates for responsible behaviors that preserve the space environment for future generations. It includes designing spacecraft for a sustainable life cycle, responsible end-of-life disposal, and active debris removal when necessary. Another aspect of space debris management is the potential economic impact. The threat posed by debris to satellites and other space assets can have direct financial consequences. Insurance costs for satellites could increase, and the need for more robust shielding could raise manufacturing costs. The economic implications of space debris extend to industries reliant on satellite services, emphasizing the need for effective debris management strategies. Public awareness and education about space debris are also increasing. Public understanding of the issue can drive policy changes and support for debris mitigation initiatives. Educational programs and public outreach by space agencies and academic institutions play a vital role in raising awareness. Furthermore, international collaboration extends to sharing best practices and technologies for debris monitoring and removal. Collaborative efforts, such as joint missions to remove debris or shared use of tracking data, can enhance the global capacity to manage space debris. The future of space debris management may also see the development of new norms and behaviors in space operations. This could include protocols for avoiding the creation of debris, norms for the safe passivation of satellites at the end of their lives, and guidelines for collision avoidance maneuvers. In summary, the management of space junk is a multifaceted challenge that spans technological, regulatory, economic, and environmental dimensions. It requires a concerted effort from governments, the private sector, international organizations, and the public. As we venture further into the space age, the sustainable use of space and the preservation of the space environment are becoming imperative for the continued exploration and utilization of outer space. The solutions to space debris will not only safeguard current space operations but also ensure that future generations can benefit from the vast opportunities that space offers.